Hi there, my name is the Innerwood. My creators have been making Kigurumi masks for more than 17 years already, and today we will share you our knowledge about the creation of Kigurumi mask shells, how they compare to each other, what is more stronger, what is more easy to manufacture, and etc. etc. And this is the patterns. As you can see, again, this is going to be in two parts. The first part will be shorter, and the second part will have a lot of stuff. So let's get started with the first part. First of all, let's talk about the purpose of the mask shell, the base of the mask, the basic material, the basic structure that is basically the one that combines all the stuff. So what is the mask shell? It is, well, think of a mask blank, the unpainted mask, and what's beneath the surface. And this thing has several purposes again, so it's not just a one-purpose thing. It has, well, first of all, it has to place everything on top, hair, eyes, organs inside, everything of that is connected to the mask shell and situated to it. The second thing is the mask shell is the thing that is going to be painted. This is, again, well, you can think of it as something that combined, but what matters to these purposes? So, first of all, it should be strong enough to withstand different conditions. So, for example, transportation, usage, anime conventions, all that stuff. The mask shell is the thing that gets all the stress of the load of the usage of the mask. So this is this thing. Also, the mask shell determines the design of your mask, how you look, how you would feel, the size of the mask, the size of the proportions of you as a character. So this is what the mask does. The mask shell does. It basically establishes the proportions, establishes the look, the shape, the face, all that stuff. So this is it. And the material of the shell and the production method is also determines how easy it would be to paint the mask, how good the paint will stay on the mask. Would you need to do a special treatment to the surface, to the mask shell, or you can just paint it over and call it a day? Will you need to have some post-processing? Will you need, after the initial manufacturing, well, all the masks need post-processing basically, but some need more post-processing than the other. And this is also determined by the mask. The durability, the ability of mask to withstand the different conditions like rain, swimming again, like something that must be compatible with some sports activities or not. And also how easy it would be to repair the mask if it gets damaged. Because, well, you know, the further the hobby goes, the more masks have been produced, the more masks have been created, the more situations where you would need to repair the mask occurs, so how easy it would be also determined by the material of the mask shell. And production time, production costs also vary from different techniques and from material to material. So if you are going to make the mask, not just to use it, This more information also will be useful to you. So all of that is based on the idea of the mask shell. Next, there are two primary approaches to the mask, to the making of the mask. It's either you have a mold or you directly build the mask. And those approaches, today we can talk about both of those approaches because both of them have their advantages and disadvantages to you as a maker, to you as a consumer. And these two approaches are they seem to mostly be related to the making process. Because the direct making, basically the 3D printing in different varieties, is a relatively clean method. It's a relatively easy to deploy method. So a lot of modern makers do opt to 3D printing. And also this method can be easily outsourced. You control the design of the mask, and then you outsource it to some manufacturer, and then get the printed shell and continue from that point to make the mask. And also because each piece of their building is basically, the additive manufacturing is basically made from scratch. Well, you have the blueprint, you have them to a 3D model, something like that, but the actual manufacturing is each time made from scratch, from the first layer on up. So it is relatively easy to change the design each time, to change some parameters. You can change the size from mask to mask, you can change some minor details from mask to mask. In this case, and each mask will cost you the same amount of time, material, labor, and so on. And the previous generation, when 3D printing was not a big thing, opted to brushing or to pouring into rotor castings into the mask, the material into the mold. And this method also has some advantages. First of all, you do not need to wait until the mask gets built up. You spend a lot less time to each mask, but you need to make a mold first. So you have a mold, and then you can do several copies of the mold. And some makers do have a set of molds they use and reuse again and again and again. And each new mask in this case gets pretty fast, so you can make several masks a day, but they will have the same shape, so this is the limit. And if you want to change the shape, to change the design, you will need to go from start to finish to make a new mold, something like that. Or you have to sculpt over the casted shell, some to do not much of post-processing. So this is the disadvantage of that. But another advantage is from the user perspective, because the masks that are cast, the polyurethane or resin cast mask, resin with fiber reinforced resin, are much stronger than the 3D printed ones. And I will again talk about this in the second section when I will tell about all the different techniques. And another thing is that you have a lot more control over the mechanical properties of the mask shell during the process of the making in this case. And in this case, you will have to design it properly, and I will talk about it again. So let's move to the next. And here we have another comparison, another axis basically. The soft shell or the rigid shell and something in between. We also have some varieties. So what's about this soft versus rigid shell? We can do masks made of soft material, we can do masks made of rigid material. Soft material is TPU, TPE, thermopolyestomers. It can be soft polyurethane, it can be silicone, it can be liquid latex that is poured into the mold. And the rigid shell is fiber-reinforced plastic. It's 3D printed shells printed of rigid plastics, something like that. So also some more exotic variants. Yeah, stay tuned. There are exotic variants. Again, for the rigid shells, it's usually medal masks or larger dog masks. Those masks are usually larger than the head, but not too large. And like the head of the performer, I mean, well, overhead can be all sizes, even larger than the whole body. Just imagine something like one big head with two tiny feet sticking out of it, and that's basically Kigurumi as well. So it's a very large head with almost nothing else. But I mean, the performance head and masks of rigid kind are not too large compared to the performance head, but always a bit larger because you need to accommodate place for paddings inside, something like that. And since those masks are rigid, they keep their shape. No matter what they're going to suffer. And they are also resistant to some cuts. But well, if you drop this mask to the stone floor, for example, it may crack and get some cracks and be damaged of this. And the soft masks is usually realistic silicone masks, or also there are masks made of soft materials for some Halloween purposes, like the cheap ones. That there are a lot of that stuff, and also the realistic silicone masks or most silicone masks that are pretty expensive. This is a luxury item basically. And also in this category we can also mention the larger masks made of soft foam, like the larger mascots, and also there are pneumatic Kigurumi pneumatic mascots that also can fall in this category. This is the larger. So it's basically those small masks that are basically some multi-reusable makeup, and the larger masks with almost nothing in between, because those masks do not hold their shape. They need either some structure or directly the head of the performer underneath to maintain their structure. And those masks would ignore any punch, any stuff. You can draw them, you can easily transport them, you can fold them, and they will be pretty fine. But if you would try to cut them, you will damage them and usually beyond repair. So repairing these masks are usually not as straightforward as for the rigid masks. And again, there are a mixed approach. When you have the front face rigid and the back part is some kind of soft, maybe just a fabric, maybe fabric with some reinforcing foam, maybe something semi-rigid but also flexible at the back of the mask. And some makers do even add a hair directly to the back part. So if you see the mask with a zipper in the back, it is the mask with the mixed front rigid part and soft back part. So again, in this spectrum, you usually have to choose between, because of the size and because of the working conditions of the mask. This is its well. And now we will slowly move to the methods of manufacturing. Well, in this part of the lecture, I will tell about methods in general. So we have 5 different methods to manufacture. Well, you probably used to some additive manufacturing. Well, additive manufacturing is basically the 3D printing, but it's not just 3D printing. There is a technique, the ancient technique, that also additive manufacturing. I will tell about that. So, well, as you can see, this is not that straightforward again. The opposite technique is subtractive manufacturing. It is pretty rarely used in Kigurumi mask making, it's almost exotic. What else we have here? Again, subtractive manufacturing. Again, this technique is basically when you remove some material. Basically, how the ancient carvings work when they made the marble statues. They get a block of material and remove everything that is everything excess. So today it can be also made by CNC machining, some milling, some using different sandblasters, sanding, milling, cutting. This realm. The next very big thing is pour or brush into the mold. Again, I will talk about there are several methods of using the mold and pouring some liquid material into the mold to make it solidify and use. And also there are some less used things, like again, subtractive manufacturing is pretty rarely used, mostly for the post-processing. And in Kigurumi mask making, I mean. And also the plastic deformation of the material, when you take a sheet material and deform it somehow to make a mask shape. Well, this is also a technique that can be used for Kigurumi mask making, and I will show you the example of it. So stay tuned again. And pattern sewing is when you have a pattern and sew it together or glue it together. So it's a pneumatic masks, it's masks made out of latex that are inflatable. That's also a more traditional masks also utilizes this technique. So we shall look at more at all of them. And the first mask making technique into the mold realm is using some resin cast, using resin compounds. It's mostly polyurethane shells, and it produces the rigid mask shells. The method basically utilizes the mold, and you mix the components of the material together and pour them in, and then rotocast through the mold, so there would be the material, usually polyurethane, sets in a thin shell-like structure. Well, it's a bit tricky because the polyurethane tends to set in an instant, so it's liquid, and then boom, it's solidified, and then you can do almost nothing. You can just wait for it to solidify, for finally solidify to become the more rigid. So in this case, you have to take the mold and rotate it in different axes, so the liquid component would cover all the sides of the mold. In this case, And after it cures, you take the mask out of the mold. The cure time may be from 30 minutes to a couple of hours. You take the mask into the mold, you trim excess material because there are always excess material. And then you get the mask. And if it's, for example, a 3/4 mask or 1/2 mask or face mask, you just straightforwardly paint it and get the result. There are different compounds, by the way. Some compounds even safe to use at home. For example, Smithson makes a lot of compounds that you can basically use at home with the open window. And you can just mix it for it. You will need some polyethylene sheets underneath to prevent some leakage. Some splashes out of the mold when you mix it. You can also need some kind of vacuum pump to vacuum out excess air from the freshly mixed compound, or you can just use them use the special pot to put it under pressure and mix it and let it solidify under pressure to prevent air bubbles to form and to make it more stable as the shell. Because air bubbles are the places of the concentration of stress, so the less air bubbles in the cured material, the stronger the shell will be. So you do this stuff. Also, there is a method when you have a two-part shell or two-part mold. So there with the outer surface and the inner surface, and you pour the material between those surfaces, and it solidifies there. In this case, you will need not to rotor cast it. You can just put the mold and inject it. But again, you will need to make some air vents in the mold to let the air out of it, some places to inject the material in the right places to prevent new air bubbles to form inside. So this is a serious topic, and it basically deserves its own lecture again. But if you want to know how to pour the polyurethane into the molds, there are a lot of tutorials, for example, by Smithson, by Star Western School of Arts, and a lot of people do teach about how to mix polyurethane, how to pour into the molds. In general, not regarding Kigurumi, but in general. So this is the details are out there already. And what are the advantages for this mask? These mask shells. Well, the first advantage from the production side is that you can make several masks in a day by this method. Several copies in a day, because you will have the one mold, and you may want to make this mold a bit more universal. For example, you may not want to cut eyes on the mold and have a smooth surface and to be able to cut any eye shape you want. Like for example here, this is one of the my older molds, and in it it is possible to cut different eye shapes, the different degree of open eyes. So from the closed eyes to an open eyes and anything in between. So you may want to do this stuff, and the other advantage of this is that you can mix some colors, some dyes, and mix it into the polyurethane and basically get the desired color of your mask basically from the mold. So you won't need to paint the whole of the mask, you will need to just make the makeup. And it also speeds up the process. Another advantage is from the perspective of the user because polyurethane shells are usually stronger ones, lightweight, strong, and long-lasting. And because the material inside, the polymer sheets inside are randomly spread and the directions are random, the mechanical properties of this material also pretty uniform across the shell itself. And again, it makes the shell stronger and it makes it easier to cut holes through without the risk to make a crack to make the mask destroy itself. So it's more easy to process in this way. And also again, it's pretty friendly to paint. It's pretty easy to paint by the conventional paints, by the conventional clear coat. So it's good in this regard as well. Then now to the next. The silicone and the latex masks is also pure into the mold technique. It is usually not water casting, but two side molds with the outer and inner layer. But also water casting can be applied to this method. For example, cheap party latex masks are made with water casting. When the liquid latex is poured into the mold gets rotated and different, and the excess latex gets poured out of the mold, and there became a thin film of cured latex. And you can repeat this process to make a different thickness of the material. And for the expensive realistic silicone mask, it may be a two-sided mold where the silicone gets injected into the cavity between inside the mold, and you get the mask. And the mold for silicone is usually rigid because silicone itself is pretty soft. And since silicone as a material can be easily damaged by touch, it is squishy, but if you cut it, you basically ruin the mask. So to make it less tearable, less damageable, there is a technique to add some fabric layer inside to reinforce the material itself, to reinforce the silicone. There are some advantages again for this method. So the biggest advantage from the user perspective is that you can have less seams on the mask. You can just get into the mask and feel comfortable inside. Well, it's not breathable in a sense as fabric materials, as resin-tie, for example, but it is soft. It's hugging. So again, in silicone mask there are special openings for breathing, not just to see through, but to breathe out of it. And since they are usually realistic, you just breathe through the nose, but not your nose, the nose of the mask. Again, this is a nice thing. So from the perspective of manufacturing, the advantage is that you need a mold for this stuff, and you can make a lot of copies of this mask. And for example, in polyurethane case, the mold leaves about maybe 15, maybe 20, maybe 30 casts and then it gets deteriorated, and most for silicone can last 50, 60, 70, and if you would be careful, maybe 100 tests. But the disadvantages are also here, and that's why there are not so much silicone masks out here than the rigid masks. And the first disadvantage is that you will depend on the mold for the quality of the mask. The better the mold, the better the quality, because these masks cannot be post-processed. You just take the mask out of the mold and that's it. All you can do is to paint it, to trim excess material and to paint it. You virtually cannot cut some excess, you cannot mill, you cannot drill it without risking to permanently damage the mask. So this is the one disadvantage of this thing. And the other disadvantage is that you will need special paints. You will need to prepare paints because a lot of acrylic paint that you can use for rigid masks. Just buy the paint in a local artist supply shop and do the stuff. In this case, they will stick to the silicone, and even if they stick to the silicone, they may chip out and crack, and there will be a lot of cracks on the surface because acrylic paints are a bit rigid, and having a rigid thin paint layer on top of a soft squishy silicone layer is basically the disaster for the rigid layer of the paint. So this is the thing. By the way, well, again, that's why those masks are usually made in premium masks, made of silicone, realistic silicone masks. Well, again, and if you will make a larger mask again, then you will have to add some structures inside of it to let the mask maintain its shape, because usually those masks, the shape of those masks are maintained by the head of the wearer or the performer themselves, so you need to do this stuff. Well, and by the way, I forgot to mention for the resin masks that resin can be clear, and for the silicone masks, there are clear silicones, but those silicones are usually a bit foggy, a bit more foggy, so it is some more complicated stuff. The next method I'm going to present to you is fiber reinforced plastic, FFF, fiber reinforced resin, something like that. And this is brush into the mold technique. It utilizes fiberglass, better polyester resin, plus glass fibers or carbon fibers as the epoxy resin plus carbon fiber fabric. And this is my favorite method, and now I can show you something. Again, this is the mask. As you can see, it's smooth outside and it's some pretty rough inside. And this stuff is, well, it's my favorite stuff. Again, so it has some pretty serious advantages because it is the most durable and reliable type of mask shell so far. It's basically the motorcycle helmet made in form of Kigurumi mark. So, well, there is a standard for motorcycle helmets, and there are different standards in different countries, and masks made by this technique, the Kigurumi mask made by this technique, can get qualified as a real motorcycle helmet for every single criteria except the range of visibility. So you can use this kind of masks as a passenger motorcycle helmet. And basically, they are perfectly qualified for that purpose. Well, and as a driver, I wouldn't sit in the driver place wearing Kigurumi mask because, well, I may be end up get safe, may be safe, but everything around me don't. So only as a passenger. Well, by the way, I had one experience driving, or maybe even two experiences, driving the car. Well, not a motorcycle, a complete car. Well, it was terrifying for the passengers, so you can understand. There is a video, by the way. So, the testing process and post-processing are, well, pretty straightforward because you just brush it into the mold, and because resin, this kind of resins do not solidify in an instant. You have the time to brush it on the surface and get the result. And also during this process, you can control the weight, you can control the rigidity, you can control the structural stability of the mask. And because you brush it into the mold, the polymer chains again are aligned across the mold itself, so across the mask itself, so it's pretty uniform, and if it gets broken, it is pretty easy to repair back. But the process is a bit messy, and you will have to trim off some excess material afterwards, so maybe you will not want to do this at home. You will need a garage or a workshop, a dedicated workshop for this. And also the resins, the polyester resin, the epoxy resin are, well, it's a chemical stuff, and unlike the polyurethanes that are specially preconditioned to be safe to use it without some protective gear, this stuff will require some good ventilation and maybe even some protective gear, especially if you do a larger mask and you have to dive into the mold to pour inside everything. Well, and by the way, for example, the polyester is pretty smelly, but in polyester case it's good because polyester is not as toxic as epoxy, and when you get into the mold too deep, you get instantly reminded that it's too deep by the smell. You get out and sort of, but the epoxy resin is not as smelly, and you can breathe in too much of it. And then, for example, when I worked with epoxy, I moved to polyester, partly because of this. And when I worked with epoxy, after it, I get this weird smell in my nose for half a day. And this annoyed me because the smell was a slightly smell, but like something annoying in the back of your mind. So it's that stuff that you will recall. Also, but epoxy is usually considered to be even more durable, even more stable, the carbon epoxy even more stable than the fiberglass polyester resin. But again, to have this kind of stability, you need to post-cure the epoxy resin into a higher temperature, like for example 70 degrees of Celsius. Again, it's a metric. So 70 to 80 degrees of Celsius, and If you do not do this, it is weaker than polyester resin. And also during my experience, I found out that polyester resin can withstand higher temperatures. For example, the direct sunlight and the heat provided by direct sunlight, while epoxy resin that is not properly post-cured can deform, can get a bit less structurally stable. But again, I need to remind you that, for example, modern airplanes, modern Formula One cars are made of epoxy resin with carbon fibers inside, and the yachts and a lot of motorcycle and car stuff is made with polyester resin with fiberglass reinforcement. So it's a serious heavy duty stuff. So if you want a mask that would last for a decade, then this is your choice basically. And again, I'm not joking about for a decade. This space is 11 years ago already. And it's not just this space was standing in a closed cabinet and took out just for lectures. So you can see a lot of stuff I was doing. I was trying then aerotube, I was swimming in different conditions, in the pool, in the river, in the lake, something like that. And you can see my face is fine. After all of that, after more than 10 years, so this stuff, so that's why this is my favorite stuff. And what would I add? Hello? Add some more of this stuff. Well, but again, I do utilize 3D printing in the process. And back then, in the early beginning, when 3D printing was not a thing, it was just an experimental technology for the artists. Well, it was already, the patent was already ended for the FDM 3D printing, and for the resin 3D printing, it was more than 10 years ago, and we experimented with it, and the 3D printers became affordable finally, and I decided to make the molds, to print the molds out of PLA, and then pour the mask inside this mold, and then destroy the mold and have the resin, the fiber reinforced plastics mask. And also, Jackson in the United States do the same thing, but with resin 3D printing. The 3D printer, he made the mold out of several parts, out of resin, and we can do this because for the resin, polyester can stick to the 3D printed resin, and this is useful for repairs, but for the PLA, for example, for the FDM 3D printed masks, well, the 3D printed layer can be easily ripped off the resin shell, so the idea of reinforcing, for example, 3D printed masks made of PLA with epoxy or polyester resin with fiber, etc., well, it's a bad idea because you basically have two masks one inside of the other, so why keep the outer shell? Again, in this case. Then, and my process again, it dissolves the process of using this mask, so as you can see, I'm already more than 11 minutes into explaining this kind of, and there is more and more and more of it, so I think there will be a separate lecture about this process in detail. So now let's move to the next stuff. And what is it? Infusion into metal molds. Well, this is the industrial scale, industrial grade of mask making. By the way, the previous method is good when you need to make one or two, or for example 10, or maybe 15 similar masks, because the silicone mold can last about 10 to 15, maybe to 20 if you use the release agents, and do not forget to use release agents every time. But resin deteriorates, the polyester resin, the epoxy resin deteriorates the silicone mold pretty quickly. But if you want to go industrial scale, you want to make thousands of similar masks, then this method is yours. And again, today we have the example of this method, and the Chinese are making the kimono Kig masks, the full Kig masks, the blinds for full Kig masks with this method. It's basically you have a metal mold, the 2 parts metal mold, or maybe more parts metal mold, and you infuse molten plastic between those molds and then cool it and open the mold, the mask drops, you close the mold, infuse the next portion of the plastic. This is high-scale industrial thing, so the tools for this, the metal molds for this is basically 2 big cubes of aluminum with a lot of engineering inside. You need to drill some cooling, for some water cooling of this mold. You need to drill some pushing rods, places for pushing rods to push them the freshly made part out of it. There are also a lot of restrictions to how to make this mold, and if you want to make it more complicated, you will have to add some mechanics inside. So it's pretty expensive. Think of the cost of a car, something like that. And in this case, this is if you really want to go to industrial scale, and by industrial scale I mean thousands of masks, 2,000, 3,000, 5,000 pieces of the same shape, same form. And in this case, you can pre-paint all the stuff. Again, all the variants with pouring or brushing into the mold techniques, you can pre-paint materials, you can pre-paint the resin, you can pre-paint silicone to make it in the desired color, and you are not limited to a certain colors. You can mix a lot of different colors, and in this case you also can do this, but mixing a new color for each mask is not viable, because there is a lot of plastic into the machine and you will need to clean all of that to have the new color. But you can pre-color the batches of the mask. So for example, today you will have a bunch of white masks, tomorrow a bunch of pink masks, and so on, and you can adjust the color each time and adjust it pretty precise. Also, the good engineered masks will be pretty durable, lightweight, and pretty cheap. For example, the one piece of this mask to manufacture costs, well, several cents, several euro cents, something like that. You need a lot of stuff to prepare, and each mask takes mask of this takes about several seconds, or maybe several dozens of seconds to be made, to be prepared, so it's a large-scale manufacturing process. They're cheap, lightweight, and you really can do a pretty complicated mask shell, but you will need to treat it as a multi-part housing, so you will have the front part, the rear part, separate ears, maybe separate extra sections that would be bolted or glued together, something like that. But it is doable, it is perfectly doable. Again, all the stuff around us that is manufactured in large scale, all the plastic stuff is made with some kind of this technique. Also, by the way, the mask can be done as a bottle, as a plastic bottle, when you have the mold and you put the bottle, the blank of the bottle into this, and you just expand it with the overheated steam, and it gets the shape, and then the mold opens and you get the shape. But in this case, the mask may be a bit too flimsy for our standards. But anyway, this is the serious manufacturing stuff. And we shall move to the next method. And this method will be the papier-mâché. Shocking, yes, the papier-mâché in this case, today we may be so used to modern manufacturing techniques that this method can look a bit too orthodox. And it is orthodox, it is the ancient method that has survived till today. And this method can be additive manufacturing technique. By the way, 3D printing is additive manufacturing, but papier-mâché is also additive manufacturing technique. We can also look at this sometimes as a brush into the mold, a brush over the mold technique when you have the master model and you cover it with papier-mâché elements. And the best variant in our case to use papier-mâché and allied techniques is to use a cheap one-layer paper towels with PVA glue, because they make the most dense papier-mâché in our case. And you have this as layers, and you get your result. And also you can cover it with some self-curing clay, say self-drying clay. For example, there is a Fimo, there is a paper clay, something like that. So you cover it and let it dry, and then you can sand it. Well, the two very first masks I made was made with this method. This is actually the look from inside of one of my first masks. Well, then other Kig also moved towards this method. So, as you can see, this method is still legit. People still use this method. And the biggest advantage of this method is that it is pretty cheap in terms of materials, in terms of the place. You can do this at home, just cover the place with polyethylene with some plastic bags or plastic sheets to prevent splashes of PVA on something really important. And in my case, when I experimented with this method, I also burned the mixer there is also blender, the blender for the meat or something like that, because I wanted to have the most dense and well-behaved papier-mâché possible. I had the term paper clay from Japanese sites. There was no Twitter at the time. It was just Japanese BBS sites and Kigurumi sites and first Kigurumi blogs at the time. And I found the term paper clay, and I think that this is a clay made of paper. And what I did, I cut a lot of white paper, well, the regular paper for printers for office stuff. I cut it into smaller pieces, then put it into the blender, and then switched on the blender to turn this paper into the dust. And because paper do not conduct heat as well as liquids, as water, I basically burnt off the knives. The plastic elements inside the blender basically get melted, but I got some amount of very fine dust, very fine paper dust, and mixed it with the PVA glue, and then I got some clayish mess that I sculpted into some stuff and let it dry. And when this stuff dried, it was as durable as a pretty dense, pretty durable wood. So it was great. But it was difficult to sell. It was difficult to post-process after that. But it was post-processable. And after that, I never repeat that experiment because I didn't have the blender anymore. So this is the story. And what else can you use from the modern materials? The Formeron, Warbloom, Wonderflex, hot glue also can be utilized in this method. While hot glue can be utilized anyway, it is pretty useful stuff. I use it every time, and I spend a lot of hot glue on each mask, even today. But in this case, you can use a hot glue as a main material as well. Well, there is some cosplay armor made of hot glue. Well, at least there was before the EVA foam became a thing. So this stuff, and again, this stuff is pretty cheap to establish. But it is messy, and the other disadvantage is that the resulting mask shell will be very rough, very handmade looking, so you'll have to put a lot of effort in it, and it probably will be heavy. Well, the fiber reinforced plastic masks also can be heavy, and any mask can be heavy, but in this case it is more probable than in other cases. So this is what we can tell about this method. And the next methods are probably pretty familiar to you, because it is FDM 3D printing. Again, FDM 3D printing. Well, it is a modern additive manufacturing technique. So we are now moving to the additive manufacturing from the most manufacturing techniques. And the next techniques would be additive manufacturing. And the first additive manufacturing was papier-mâché, and this is the second additive manufacturing technique. And today it is easy to establish. 3D printers get cheap the last days. The filaments also get cheap, and you just make, and there are 3D models online to print, and all of that a serious problem. Well, and the problem is not because it is a 3D printing technique, but because people usually utilize it as an artist, but not as an engineer. And I have a full separate video about this stuff. The full video about this stuff is about how to make the 3D printed mask, or FDM 3D printed mask, better, how to design it better than most of the modern stuff. And I even designed a mask and put it online for everyone to see, to inspect, to use, to print, with those engineering elements in it, so people can see how it is properly made. And again, the other thing is that people usually opt to PLA because PLA is the most widespread material. It is used in most cases, and it is cheap, it is easy to obtain, and it is the raw material. PLA will not withstand hot weather. It can break. It's not very good for the paints to stick. There is a better alternative, that is PETG. Basically, PETG is way better than PLA in this case. So if you want to use this method, please use at least PETG. And if you can also opt to ABS. This is an even better alternative, but ABS is trickier to print. So if you don't have a printer that can print ABS, then print with PETG. And you may probably want to print with some more extreme materials like PEEK, like nylons, something like that, but you will need to have a special 3D printer for that, and you will need to buy way more expensive materials for this case. And again, PETG or ABS can be easily painted over, but nylons, PLA, for example, nylons or PEK may not be so easy to print because they made chemical resistant, so the paint may stay to the surface, but it won't stick to the surface, and it will be peelable easily. And PLA is somewhere in between this. You can paint PLA and with acrylic paints, and those paints will seem to stay on the surface, but the difference between the temperature difference, the instability of PLA in very high temperatures and so on may just tend to crack the PLA to the layer lines, and the layer lines is another problem with this stuff. Yeah, I do not like masks that are printed with the thickness. Yeah. So the layer lines, again, because 3D printing process inherently have internal stresses, well, it's easily crackable along those lines, and because of the shape of the mask, well, people who do 3D printing in commercial purposes research will tell you that 3D printing is a technology that allows us to make a final parts, not just the prototypes, not just the forms, not just the mold, but final parts, very fine. But there is specifics, and Kigurumi masks are basically a thin, large shells, and you cannot position the Kigurumi mask in a way that there won't be layer lines through the surface of the mask. And this makes the Kigurumi mask anisotropic, and because it's a shell, it's pretty easily deformable, pretty easily squeezable, and those squeezes introduce a lot of stress in the mask, and because it's already weakened along those layer lines, it makes masks more easily breakable. Then, for example, resin polyurethane masks in this case, so you get this element. And again, if you design the mask properly, you add some reinforcement ribs inside the mask, etc. Then you can offset this problem a bit. But usually the usual process of creating Kigurumi mask out of the 3D model involves just adding some thickness to the mask surface and call it a day. So again, this has done some problems, and there are people who try to reinforce those masks with fiber reinforced plastics, but again, as I've said in the fiber reinforced plastic sections, you basically get two masks, one inside the other, and PLA is not as sticky, and even PETG is not as sticky to the resin, to the polyester resin, and they're basically held together by the roughness of the surface, and you can separate them easily, pretty easily. And also they have different temperature expansion coefficient, so it will be fine in the same circumstances as when it was made. But if you, for example, transport it in the summer heat or transport it during the winter somewhere, and the temperature gets too far away from the manufacturing temperature, mask can just crack. So reinforcement is not a good idea in this case. But unless there is some interesting exception for 3D printing, and this exception is the flexible chemical elastomers and the CPU in particular. Right now I'm preparing the experiment of making the Kigurumi mask to print the mask out of TPU. And when I will finish that process, I will show you the results. So in TPU I trust a bit, well, at least enough to think that it may be an interesting idea. Well, you can see this is TPU, this is painted TPU, 3D printed painted, and those ears are already showed their durability. So there may be some hope for the mask making, and since TPU is soft, it will introduce some interesting effects. For example, recently I made some part of the mask out of TPU, some the elephant ears and some horns for masks printed out of this material. Well, and so this can be an interesting stuff that may have less disadvantages than the other FDM dependent materials. But TPU have another disadvantage is that you will need to paint it with special paints. You will need to make special paints to paint it. As usually, the colors available for 3D printing, so if they are 3D printed, are not compatible with its structure design. It may be too pink or too blue or too other, because there are usually some general purpose colors and a limited range of colors. like again, going into the mold techniques where you can just add pigment and you have the variety of colors. In this case, you have a limited palette of colors and you will need to paint the mask in any way again. And now I shall tell you about the one additive manufacturing technique that is resin 3D printing. So what is what is resin 3D printing? It is another 3D printing technique. When you have the material, the resin, poured into the printer, the DLP usually, and you get the final shell made of resin, and it may sound durable because, as you recall, I told about polyurethane resins, polyester resins, and usually this kind of resin is polyester-based resin, but there is a crucial difference because these resins are not reinforced. Resin and not reinforced resin is brittle. It is rigid, it's pretty rigid, but it's brittle. So why this method is popular? It is popular because it is very easy for manufacturing. You get the mask fast, even faster than the 3D printing that takes about 2 to 5 days. So this can have just a 1 day for the Kigurumi mask, but usually about 2 days for the mask. Each mask can be unique because each mask made from scratch, basically, from the model. So it's a new model, put it in it, you get another shape. Also, the result of this, the masks are smooth outside, the masks are pretty clean looking inside. And and as a product, this looks great. But the process of making this kind of masks, well, it's a bit more messy because it requires some chemicals to wash off the excess resin, to post-cure the resin. You need to wash it with isopropyl alcohol. You need to cure it with ultraviolet, and it's a lot of stuff, but this stuff can be compacted into some short time, about half an hour, and you get the result, and another half an hour when you clean the printer and prepare it to the next mask. And in this case, it can be pre-colored. There are special pigments for resins, so you can pre-color the mask shell when it is printed. So this may sound great, but there is a catch. 3D printing when it was first introduced to the market was called rapid prototyping. So it was usually utilized for making some prototypes to see how the final product will look like. And those products could even have the properties of the final product. But since this stuff is not reinforced, this is pretty brittle. And because of the nature of 3D printing, again, different layers, of the resins have some shrinkage factor. They have some shrinkage, and because the layers up to the layers that are already made are cured, they are not 100% cured. That's why we post-process or have a post-curing, because this allows the layers not to shrink all the way down and introduce less amount of stress. But again, polymer chains are also usually put through the layers, and again we have a large shell, and because it's a large shell, we have large stresses propagating through the shell when it is squeezed, and because we have those layers, and between layers, the one layer is cured more than the other, and we have some internal stresses. When this mask cracks, and this mask usually cracks a lot, you have a little interesting problem that it may be not repairable. So, for example, this mask was sunk improperly. This is the broken out part of the mask, and you could not glue this. There is a crack here, and you could not glue this crack because the length of this crack for this side and the length of this crack on this side, there are some indents here and there, and you can see, if you would inspect this closely, you can see that there is an indent here and in the notch here, so they would be naturally, this is naturally the one place that cracked from another, and the length of this part of the right part, the right, my right, your right part of this crack and the length of the other side of this crack are not aligned properly. So if you align it here, it would be misaligned here, and if you align it here, it would be misaligned here, because of the different amount of cure shrinkage of this stuff. So again, treat these shells as temporary as you treat the FDM shells as temporary shells to try to make the mask, try to have it. It's about the stuff for a couple of festivals. It may last a year, maybe 2 years if you would store it properly, and it's not as prone to temperature deformations. It can withstand temperature fluctuations better than organically deformed mass, but it is, you need to be careful with this mask. It's not this stuff. This stuff is not as immortal. Also, again, since polyester resin can stick to these shells, you can reinforce these shells with polyester resin, but again, why keep the 3D printed mask shell? You can just make a 3D printed mask mold and have basically the fiber reinforced shell just as this. You do not have this extra weight. It becomes an extra weight. As for post-processing, this stuff is pretty post-processable. If you won't crack it during post-processing, then it's okay to go. You can drill it, you can sand it, and also there is an aspect I didn't mention earlier before, but as in case of resins, as in case of a pen, in this situation, you cannot just pre-color it, but you also can make a see-through element. You can make a transparent elements, transparent elements tinted into a certain color. This method would allow you to do this stuff, and if you want a high-quality transparent stuff, this method may be the best. It may be even better than polyurethane resin. That is the second best. That is maybe the second best method, and better than the fiber reinforced resin, because there are clear resins, optical epoxy resin, optical polyester resins, and those resins, when you put some fiber inside, the fiber basically become invisible. But this thing is easier to make smoothly without any bubbles than the other method, and you get all the surfaces. So if you need something transparent, then you may think of this method is variable. And again, transparent stuff are usually not as strong as non-transparent stuff. The next thing also 3D printing, and it is less selective laser selective laser welding. I forgot the one. Also the rapid liquid print method. Well, I combine it with the two different methods. Very different, but both of those methods require industrial equipment. So, in a sense of manufacturing, you may opt for this method only if the other methods will not deliver you the results you want. But these methods are pretty flexible, and you can have pretty good quality masks. High strength masks, also, well, pretty close to FFA if you want. You can have the see-through masks, but in these cases, you probably will have to choose the colors that are provided by the manufacturer. Probably the choice of colors are pretty limited in this case. And if you use LP is a soft silicone printing in the gel. And in case of our LP, you won't even be able to post-process the mask. But if you will use the titanium powder or nylon powder, you probably will be able to paint the mask easily and to post-process as well. Titanium is not easily to post-process, but it's post-processable. Okay. So again, requires special equipment, but as everything that requires special equipment, there are interesting varieties of materials. Can titanium Kigurumi mask while doing this method. So what else? Again, the batch size for this is just one piece. Each piece is a different batch. And this takes time as any 3D printing method. Now we are moving to milling and coloring methods. What is it? Again, you have a block of material and you just chop off all the excess to get the desired shape. This method is usually used for larger masks. And well, this is one from old Japanese site. Sorry, I don't forget. I forgot. I took this image, and we have the styrofoam block, and the maker just carved out the mask shape. Well, this particular mask shape was used as a master model, and then it was covered with fiber-reinforced plastic, and that fiber-reinforced plastic was served as a shell. But they could usually just leave it as is and just carve some space inside for the head. Again, this is usually some, well, you can use, for example, marble or wood for this type of manufacturing, but usually it's a lightweight form. Maybe styrofoam, maybe some soft foam. So the mask shell itself serves also as a padding. And because this stuff is not very rigid, it's usually have thick walls. For example, it can be 5, 6, 10 centimeters wide or even larger. But you can make a large, lightweight fence with this kind of stuff. And also, then, if it's a soft foam, it is pretty carryable at home, so you do not need a special place for this. You just need a good vacuum cleaner to just clean all the mess you made and just put it in the one bag, something like that. Because you chop, and then you need to get this. This method is often used for making air full sheet heads and for large muskets. So the biggest advantage of this is that the large heads will be lightweight, and it is hole-friendly manufacturing method. But also there are special CNC machines that cut foam into desired shapes. You can use power tools for this stuff. And it's the materials are maybe pretty affordable. So again, a good approach, but those masks won't be. But those masks can be not be very durable, especially if it's rigid to styrofoam. So it may be a temporary masks. And usually you cannot pre-color those masks, so you will have to cover them with some kind of surface. To paint that surface, so you will need some putties and post-processing. Well, basically, this is post-processing the block into the Kigurumi mask. The next method is pretty unique. That's what you're forming. Who would guess that Kigurumi mask could be back-formed? Well, I did a long time ago, and I tried different methods, and finally this year I can present you this. This. This is vacuum formed mask shell, and this is a method that allows us to make a batch of relatively cheap masks, not as cheap as infusion into metal into aluminum shells. But if you want a batch between 50 and from the 20 to several hundred of masks, this is the method to go to. And as any large-scale manufacturing methods, this one have a lot of limits. You need to prepare a special tool, a special form to do work forming. You need to know your materials. You need to know how those materials behave. I tried different materials for that. I tried edgy, I tried ABS, I tried polystyrol, all that stuff. Well, and the limitations of this method regarding the color is that you have to choose a limited palette of colors, and usually there is a more limited amount of colors than in 3D printing. But you can do see-through masks with this method as well. Just use a see-through clear PG. And by the way, a lot of people who do display visors use this method to make those visors. the famous Daft Punk helmet, for example. The cosplay of Guy Manuel was made with this method a lot of countless times. Other methods other stuff, other see-through visors on the helmet also used this method. And the thing is that you can, if you know the process, if you know how to do it, if you know how to prepare the tools, how to make this, you know the limitations of the process, then you can simply do this stuff. And the amount of time you spend on each masking this stuff is about half an hour, maybe an hour if you have several parts. You can make a full head mask with this method by making several tools and several parts, for example the face part, then head part, head part, the rear part, and the results can be pretty lightweight. For example, this shell weighs about 400 grams. This shell, not the shell, not this top protective. This face weighs about 180 grams, so very lightweight. What else? What else? No, well, basically that's it. That's it for the method. And the next method of plastic deformation, also plastic deformation category, metal shaping. Well, I promised something strange, something different. By the way, this person, this is the Russian metalsmith who did cyberpunk cosplay for a pretty high-profile cosplay, and that cosplay was made of metal. It's an android girl, and the full cosplay was made of metal. Basically, the medieval armor, and in our case, the context of our lecture is a medieval helmet, just in the shape of a cute anime doll. Why not? Again. But this method is tiresome. You need a special workshop, you need a special tools, you need a special skills to do this. But by the way, if you go through all that stuff, your grandchildren will pass it to your offspring, to their descendants. So this stuff will live forever. This stuff will protect you. Well, there are some disadvantages because it's a metal sheet and they may have the sharp edges, so you will need to pay attention to that. Not that just a disadvantage, you just need to pay attention in this case. And also, since it's a metal sheet, it can be bent a bit, something like that. But the repair is basically you just need to bend it back. The other problem with this is that you will need a special paint, the paint for metal, and a certain treatment. By the way, once I was discussing and guiding a person who made a pursuit mask out of aluminum. It was an interesting experience. Also, this is steel, but again, you have the point. Also, the problem is because it's a metal, this stuff is heavy. So, again, and give European helmet. By the way, you can claim that this kind of Kigurumi masks was popular even in ancient Greece and in ancient Rome, but they prefer the male Kigurumi masks with some extra details, but there are some in museums worldwide, so why not? Why not? Well, just too special, too expensive for mainstream. But if you want, you can do this. And what else? Oh, again, there is another category of methods, and the processing part, pattern sewing technique. This is common for the pursuit making when you then make the exterior of the pursuit masks. Also, for example, this is Thailand, one of my favorite manufacturers, for making the fully inflatable, fully latex masks. Also, Lanka made this thing out of, there was some rivet shell inside and the foam, and on top of the foam we have the fabric. So, this stuff, as you can see, there is some support section inside, maybe it's an air support, air support, that's why I'm sorry, it's already so much, 1.5 hours already, so again, air support, inflation. It can be inflated with air. The mask structure can be held with some foam inside, something like that. And the problem with this is that it can be post-processed. You can paint it, but usually you do not need to post-process it. You just cut the sheets, glue them, put some layers of material to make different shapes, different makeup, etc. Add some paint. Fabric utilizes a textile paints, latex utilizes latex paints, and different patching technique on top of the other. And this again works well for the furry characters, for some abstract characters like pumpkin heads. And in case of human shaped characters, this may look some, well, some weird. But again, what can I say? But again, it's a pretty decent technique, and it's used again in larger hairs in pneumatic muskets. So those Android style muskets also utilize this technique. This is it. Oh, sorry. Android style muskets also utilize this technique, and if you are good in patterns, in sewing or in gluing latex, you can go for this technique and have a pretty good, pretty interesting result. Again, it's easy to transport, and all the advantages of the soft masks and disadvantages of the soft masks are viable here. Now, this is the comparison table. So again, to remind you about all this stuff, so what can I say? We see here all the techniques I mentioned. Again, FDM rigid and FDM CPU was on the same slide, but since those techniques have some differences, I put two different rows for them. But SOS and LPS are different techniques, but since those are pretty specialized techniques, I just combine it together. So what do we see here? Mission equipment is whether you can use this technique at home. For example, resin cast, you can use at home. FDM 3D printing, you can perfectly use at home. You can just put the 3D printer at the kitchen and let it run for several days and get the result. And then sand it a bit in a bathroom so you can get this. While fiber reinforced plastics require a workshop because it's smelly, it needs a good ventilation, and infusion molding or SLS and LP techniques are industrial grade techniques that require industrial equipment, a lot of electricity, large machineries, some specialized machineries, some laboratory equipment. So this is basically green and yellow is what you can afford if you're a small maker, and the red is what you can afford only if you are a large maker who are ready to do a serious investment. Labor per unit is how much labor you need to put into each mask shell. So not much is that you need to take it out of the mold, for example, for a silicone latex, and just trim excess material and discharge the paint. While, for example, infusion molding is you basically get the ready part, you just need to cut some screws, so also almost nothing. A lot of work is that you need to trim a lot, you need to sand, you need to do a lot of first stage post-processing to make the mask smooth, to make the mask good. So cut, trim, drill, something like that. And at tone is that a lot of more, you need to put a lot amount of work into the dedicated mask shell. For example, Takayama shell will require you a lot of work. You need to glue it together, to mix material, to put it together, to sand it, to put another layer of material, and do it, iterate it several times. Usually through the several days, well, maybe 1-2 hours per day, but several days. 1-2 hours per day, you add some material, let it dry, then sand it, clean it, etc. Then again let it dry, so this is like that. Then milling and carving, metal shaping, it's a lot. And again, vacuum forming is pretty not much, you just have not much to work, you just vac form it and trim it and it's ready. Optimal batch size is how much each of each mask shape is viable to make run per your tool and for your equipment. So one for 3D printing of papier-mâché, one is basically you need to spend a lot of time for all the time you need to spend is basically each mask is made from scratch. Maybe you have the blueprint or 3D model, but each mask is made from scratch. These smaller batches is basically you have a mold that can last, for example, 10 castings for fiber-reinforced plastic. It's a moderate amount. Again, I've said that you can make 15 or 20 castings for a paper, but 10 is basically the lower bound that you can achieve, that you usually can achieve in different situations. Something like this, from 1 to several stuff. And 3,000 plus for infusion molding is because the less of that amount is economically senseless. So again, work forming is also senseless to do less than 20 of them. It becomes too expensive for each unit, and 800, well, it's a good estimation. You probably will be able to have the most for this loan in this case. Well, I managed to have two and form that lasted about 600 tries, something like that, for all those years. Then, durability. Durability is so durable how strong the mask is. And, for example, fiber-reinforced plastic is pretty durable. Again, motorcycle helmet. The metal masks are durable. Then, SLS masks, if those made out of titanium powder or nylon powder, can be pretty durable, and if those made out of different materials can be pretty brittle. So it depends. Again, FDM, the rigid FDM is weak, so it can be easily broken. And the PPU looks to be pretty strong in this regard. So like that, basically, and again, it's how long the mask will last. So this is this time. Repairability is how easily it would be to repair the mask. Would you just need some epoxy glue from convenience store or some special materials? And if you would repair the mask, for example, if you would repair everything, you can just glue it together, glue the cracks together and just sand it so after it would be painted over, there will be no trace. And in silicone or latex stuff, you will need a special kind of glue to glue it together back, and there would probably be a trace of that, probably be some scar of this place. So, for example, FDM, the rigid FDM, is also not easy to repair, especially if it was PLA, because it usually not just cracks, but it also spreads out and deforms around this. So, for example, once I got a mask that we get a mask to be repaired. The mask was 3D printed and it just exploded in some areas, and I just took the mold and made it out of fiber-reinforced plastic and just sanded down all that irregularities to make it smooth again. So it was the result. So this is all that stuff. Again, something would be easy, something would be not for each repair. And, for example, infusion molding masks or rock forming masks are too cheap to so cheap that it is easy to just get a new one instead of trying to repair the existing one. So this is what the repairability is saying here. Again, medium is something between the easy accessible and hard accessible. So you can repair it so it will look like a new one, but it will be a bit more tricky than just taking the two compound epoxy from the convenience store. Soft to touch. Soft to touch is either the mask is rigid or soft. So depending on what are you going to make and what requirements of your mask shell are, you basically chose one of those options. So again, there is no right or wrong. In a variant, you chose what is important to you and deal with the disadvantages accordingly. Weight is, well, usually the low weight is below 400 grams. It's very lightweight, you almost don't feel the mask shell in your hand. From that to about 1500 grams is the medium. Fiber reinforced plastic, for example, can be 600 grams and can be 1500 grams, depending on how new the resin is, how easily it is to get painted over something like that. I will start with this. The surface post-processing is when you make the mask shell, you finish the first stage post-processing, you finish making it smooth, so and how easy it is to continue doing some post-processing. For example, you want to make some extra holes for attaching some elements, or you want to change the shape of the eyes, of the mouth. So possible is that you can do all this stuff with tools or just with handles, with power tools. Not possible is that any attempt will probably ruin the mask shell. And required is that you will have to do all that stuff because you probably will require basically the amount of the post-processing is so much that it's not just some optional thing, it is just a serious part of the process, not just trimming some excess material and finding some irregularities, but some serious amount of work to smooth the process. And again, for milling is basically the method, or for metal shaping is basically the method. You just have a block of material, the sheeted material, or a block of material, and you post-process it till you get the right shape. Can be pre-colored. What is pre-colored is you can either add some pigments into the mix of the resin, for example, and get the mask, the mask gets out of the mold in the right color, or you will have to just choose from one of the existing materials. Either yes, you can add some pigments. No, you have a limited range of colors that you have to choose from. And limited is basically that you can pre-color material, but you have to pre-color a batch of materials. For example, In fusion molding, you cannot pre-color just one mask, you have to pre-color a batch of masks. For example, today we have whites, tomorrow we have grays, a week from now we have masks for the sky blue. So there are a batch of the masks of each color. This is the limitation. And again, the SLA, the resin 3D printing, also you can mix it into the resin, but not all the resin will be used, and you will have some extra resin that is pre-colored that you will have to somehow use or throw away. So it is the limitation. So you have some extra, not just one mask. Again, there must be see-through, can be clear. So can we have the clear resin? Can we have the clear polyurethane? So we can make something clear of it. And again, resin 3D printing can be clear. And again, it's the best variant for clear variant. The second best is resin cast into the mold that has both outside and inside surface. And also the vacuum forming is the second, again, compare than resin cast. And then we have the FFP. Oh, by the way, infusion, plastic infusion can be clear and it can produce very good results, but again, it's industrial. By the way, a lot of sunglasses, a lot of helmet wires, all the stuff made by the infusion. So it is the zero best. The first best is let's bring the zero best is easy. And the ease of paint is about either you can use just a stock paints, the basic acrylic paints, or oil paints with this stuff. This is the easy variant. Then mild is that you have to prepare the surface, maybe with the base coating, something like that. But the rest, the process is straightforward. You just need a coating for the foundation. The special paint is that you will have to either mix your own paint for this process or buy a pretty specialist paint that is specialist for a certain material, for a certain chemical that are used in the process. And not possible, or almost not possible, is that you will have to use another methods to introduce color into the mask shell. For example, a pre-colored latex in the case of inflatable latex mask, and different layers of different colored latex to make those shapes and makeup. So that's it. That's our comparison. A quick summary. And thank you for watching. This was a pretty long. Today we were pretty long time together. I'm glad that if you made it through, then you are great. So thank you very much. Again, this is my Telegram channel. And see you next time with some more knowledge. Bye.